classes, and welcome to today's Grade 12 Math Show. Today we have a special revision lesson on trigonometry. We have selected highlights from lessons shown early in the term to help you revise and prepare for your June exams. You can download the notes for today's show from learnextra.co.za/live. Now it's time to get on with today's lesson. Please post your comments and questions on our Facebook page on facebook.com/learnextra or on Twitter @learnextra so we can help you with your revision.
I'm going to do number 2 first because I find the fractional ones are the ones that people really struggle with. And I'll leave you guys to try the first one for yourselves. F of x is equal to x squared plus x. Try that one for yourself, defining the derivative from first principles. When you do the first one, this should be your answer. And if you get that answer, then you know that you've done it correctly. Okay, so that's the answer for the first one. But I'm going to look at the fractional one because, as I say, that's fractions for some reason people battle. Okay, so the first thing we do is we write out our formula. It's the derivative of f at x is equal to, and yes, you have to keep this limit in every single step. Okay, so limit as h approaches 0 of f of x plus h minus f of x all over h. Guys, you can do each of these separately. So you can find f of x plus h and then f of x and then, put them all together. I'm going to do it all in one just to save us a bit of time as well. So I'm going to say limit as h approaches 0. Now for f of x plus h, it means wherever there's an x, and I'm doing question 2 here, so we find the derivative of 1 over x. So that means wherever there's an x, I need to put in x plus h. Okay, that's what f of x plus h means. So I'm going to get 1 over x plus h, because remember where there was an x, I'm putting in x plus h. All right, minus f of x. F of x is the original function, so the original function is 1 over x. And this is all over h. Okay, then that's equal to, once again, we bring down the limit as h we also, instead of saying approaches all the time, we can also say x tends to 0. So you'll often hear us interchangeably saying either x approaches or x tends to 0. It's the same thing. Okay, so I've got 1 over x plus h minus 1 over x all over h. It's a fraction. In the numerator, I need to find an LCD. And my LCD is going to be x times x plus h. So I'm going to times this fraction by x over x, and then this one by x plus h over x plus h. So my LCD is x times x plus h. All right, I'm going to times the 1 by x, and then the second bit by x plus h. You'll notice that I immediately use brackets because this minus sign tells me that signs are going to change, and if I don't use the minus sign with the brackets, I'm going to mix the signs up. So important that you use the brackets. And that's all over h. All right, let's simplify a little bit further. So in the numerator, I now get x minus x, because I'm timesing the minus into the bracket. So negative times a positive is going to give me a negative h all over x times x plus h. And what I'm going to show you here is I can also add in the h from the very bottom. I can put it here next to the whole denominator. Now the reason for that is if you've got x times x plus h in your denominator here, remember, you're going to tip and times that, so that's going to become, so it's going to look like this. I'm just going to do it on the side here. So I've got x times x plus h, and then we've got our functions here on the top, and then I'm dividing by h. All right, so that's the same as saying whatever in my numerator over x times x plus h. And then this, remember, whenever you're dividing, you tip and times. So it's going to be times, this is h over 1. So if I tip it over, it's going to become times 1 over h. And so that, you see, they all just get multiplied together. So it's going to be x times x plus h times h in the denominator. So you can write it like that immediately. If you don't like to do it that way, you can do it the long way. And you can keep the h right till the end and then simplify in the end. All right. X minus x is going to give me 0, and I'm just left with negative h all over xh times x plus h. All right, and you'll see what I said to you happens before. If you've done it correctly in your second to last step or your third to last step, depending on how much you write out, in the numerator, do you see that we have no terms in x? All we have are, well, in this case, it's just 1, it's just an h, but all you'll be left with generally is terms with just h. Okay, that's important. If you don't get to just an h in that step, you've made a mistake. Okay, so this is equal to limit, just terms in h. Okay, it doesn't have to be a single h, but there's got to be terms with h in them. So what we can see is going to happen here is that h and that h is going to cancel. And we're left with minus 1 in the numerator over x times x plus h. At this point, we can tend h to 0. So in other words, we can substitute h is equal to 0 in there. And I'm simply going to be left with minus 1 over x squared. Because if this is 0, I've got x plus 0, which is just going to give me x in that bracket. And then x times x is x squared in the denominator. So I'm left with minus 1 over x squared. Okay, and that is the derivative from first principles of that function f of x is equal to 1 over x. And remember, if they say to you from first principles, you need to do it in this whole long format. Okay. Okay, guys, so remember we were looking at first principles before we had that break, and we had that long formula for first principles. Now, if every time you had to find the gradient, you had to use this long formula, it would take forever. You'd never be able to finish the rest of your exam paper, so it's really not that nice. So that's why we've got this whole set of rules, which makes it really cool because it's really quick now. And we've got all these differentiation rules that help us to find the derivative really quickly. Okay, so if you learn the rules, well, you have to learn the rules because you need it for your exam, but when you learn the rules properly, you'll see that it makes life so much easier because you don't have to do the long first principles method. Okay, all right, so the rules for differentiation. The first one, the derivative of a constant is 0. So if f of x, if your function is equal to some k value and k is a constant number, then the derivative of f at x would just be equal to 0. So for example, if I had f of x is equal to 7, right, then the derivative of f at x, because the function is actually a constant number, the derivative of that would be 0. Okay. Then the power rule. If you've got a function y is equal to x to the power of n, then the derivative of y is going to be equal to n. You take that n, that power, you times it to the front of the x, or the coefficient of the x, and then you subtract 1 from the power. So if y is equal to x to the power of n, then the derivative of y is n, so I've brought the power to the front, times x to the power n minus 1, and I subtract 1 from the power. Okay? We'll go over that rule when we look at more examples. And then if we have f of x equal to k times x to the power of n, so now instead of just x to the n, you've got a coefficient here, so some number. Then all you do is it's exactly the same rule. You bring the n to the front, but you multiply it by whatever constant was already there, and then you subtract 1 from the power of x. Okay, while we're on this, I just want to show you the different ways, because you'll see I've written here f of x and I've got f dash x, and suddenly I'm using y prime. So some of the different ways to represent the derivative, the common one, f dash x We also use y prime, or g dash x, depending on your function. Another way that you'll often see is dy over dx. Okay, and so these are just the different ways you can write derivatives. Or you might see this thing, dx, and then a bracket with a whole function in there. Okay, so those are all different notation to show that you are finding the derivative. So that's just the different notations for derivatives. Okay, now if you want to be really, really good at this section, then you need to remember all of your exponent laws. Okay, that's the only trick to being good at differentiation. You need to be really good at exponents. Okay, so if you've forgotten all of your exponents, please go back and revise that. That section is essential for this section. Okay, remember in maths everything builds up. So you need to know exponents really, really well to be able to succeed at differentiation. Okay. If they just say find the derivative of, and they give you some numbers and variables and that kind of thing, if they just say find the derivative and they give you the function values, you're just going to use the rules, okay, the power rules and that I've showed you now. You won't do first principles. If we want you to derive by first principles, we will say find the derivative by first principles. Okay, but if you generally just ask to find the derivative of a function, you're just using the rules. Okay, I'm going to try and get through as many as possible. So let's look at the first one. We are asked to find the derivative of f of x is equal to 3x squared plus 8. All right. So we set it up if the derivative of f at x is equal to, now we're going to use the power rule. So the power rule says, okay, let me write it down for you again. Remember, we had if y is equal to x to the power of n, then the derivative is equal to n times x to the power n minus 1. You see what we did? We subtracted 1 from the power, and then we also brought the power to the front and multiplied by x. Okay, and if there was a coefficient, we would have multiplied by the coefficient. So here we do the same thing. We're going to bring that to the front of the 3, multiply the constant by the power. So it's going to become 2 times 3. The x will stay exactly where it is, and all we do is from the power of 2, we're going to subtract 1. Okay. Then remember, now we've got a constant, an 8. And remember, we said the derivative of a constant k is equal to 0. So if we're looking at a constant, any constant, the derivative of that will be 0. So therefore, I don't put anything down for the 8 because the derivative is 0. You don't have to write anything. You don't have to explain this or whatever the case is. We know that you know that the derivative is 0. So don't worry about putting anything there. Okay, so f dash x is equal to 2 times 3, which is 6, times x to the power 2 minus 1, which is just 1. Very important, please, once you've started deriving, once you've started using the rules, make sure you show that you are deriving. So you need to put your symbols in the right place. So you need to, at this point, when you've started deriving, you need to have f dash x, the derivative of f at x. You mustn't have f of x. Okay, very important, that notation. Get into the habit of using the correct notation from the beginning. Okay, so once you've started deriving, you need to put in the right notation. Okay, hopefully you guys were able to follow that and it's easy so far. We're just using the basic power rule. Okay, we're going to look at another example. This is example B. All right, and I'm going to have to just call that back up because I cannot see it. So we've got 4x cubed plus a half x squared plus x. Okay, and then this was f of x. All right. So I've got a whole lot of powers here. I'm going to use my power rule, but what you need to remember is also your rules for exponents, a half times x squared, okay? If we had written x squared over 2, what does that mean? It means a half times x squared. Okay, so if you see a half x squared or if you see x squared over 2, the same thing. All right, so now I want to derive this. So I'm going to say f dash x. It tells the teacher that you've started deriving, okay? Once you've put that symbol in, you need to start deriving every single term, okay? So what do? We take the 2, the power, to the front, to the coefficient, and multiply the 2 by the 4. And then we've got x to the power. From the power 2, we subtract 1. Okay, so I'm just applying the rule. And I'm going to do that for every single term. So it's going to be plus, and then again, I'm going to bring this 2 and multiply it to the half. All right, this was actually a cubed, guys. Sorry, my mistake. The question was originally a cube, and I just took it down incorrectly. So that's a 3. And that's a 3. Okay, here we've got 2, x to the power of 2, so it's going to be 2 times a half. And then x to the power of 2 minus 1 plus x to the power of, this is a 1, so again the same thing, take the 1 times it by the x, and it's going to be x to the power 1 minus 1. Let's simplify that. So we get 3 times 4 is 12, x to the power 3 minus 1 is 2, plus 2 times a half is 1, x to the power 2 minus 1 is just 1, and then I've got plus x to the power of 0, and this is why I was saying exponents become very, very important, because if you've learned your exponents, you will know that x to the power of 0 is just 1. So our
Okay guys, I hope you're enjoying this revision session. If you are struggling and need help, remember to post on the page or send an email to helpdesk@learnextra.co.za. Now it's time for a break, so don't go away. We'll be right back. Welcome back, guys. I hope you are getting into the idea of revision. Please let us know how you are doing. I'd love to chat to you on the page or on Twitter. Enough of the chat. Let's get back to revision now.
And we are talking tangents and graphs. All right. The most important thing that I've done today, if you've missed everything and you're just tuning in now, those that were paying attention will tell you, most important thing you've learned today is that the gradient of the tangent is equal to the gradient of the curve at the point of contact. We've done 2 examples. The first one, we looked at finding the equation of the tangent, all right? And in the second one, we were given the equation of the tangent, we were given the curve, and we had to find the point of contact. Okay, so just the 2 different types. Now we are going to once again go on to finding equation of a tangent. So for those who are a little bit confused about how to do this, we're going to do another question on this. In this question, we are asked to find the equation of the tangent to the graph y is equal to 2x plus 1 squared times x plus 2 at x is equal to 3/4. All right, so let's get started. Now, if we were to draw this, this is actually a cubic graph, which we haven't touched on yet, but it's going to have something to the power of 3. Your cubic graphs are going to look like that, and they're going to look like this. But we will go into more detail as the weeks go on. In fact, next week we might be looking at cubic graphs. All right, but I just want you to keep that shape in mind. Some of you may have seen it before, others may not have. So what I'm going to do is I'm going to expand this expression, and I'm going to get something that's cubic. So remember, 2x plus 1 squared just means 2x plus 1 times 2x plus 1, and then times x plus 2. We have to expand it, okay? There's no short way about it. You've got to expand your equation before we can do anything. So 2x plus 1 squared is going to give me 4x squared plus 4x plus 1. And then I'm going to times that by the binomial x plus 2. Alright, and remember, all I've got to do now is just distribute the terms from the second bracket into the first bracket. Alright, so x times 4x squared is going to give me 4x cubed. 4x times x is going to give me 4x squared. 1 times x is just going to give me x. Okay, next we're going to times the 2 into the bracket, so times it by every term. Okay, 2 times 4x squared is going to give me plus 8x squared. 2 times 4x is going to give me plus 8x. And then 2 times 1 is just going to give me 1. We add our like terms, so we get 4x cubed plus 12x squared plus 9x plus 2. So as I was saying, you see we get a cubic expression, and a cubic function looks like those two graphs. You don't have to really worry about this now. I'm going to go into much more detail in the following weeks. All right, but we are asked to find the equation of the tangent to this graph at the point x is equal to 3 over 4. So this is what's happening. We've got one of these graphs, and we have a tangent that's just touching it at a point, and all they've given us is the x coordinate at that point. So we know that x is 3/4, but we don't know what y is. Okay, and they want to find the equation of this tangent. All right. Now remember, once we've simplified all of this and we've got our expression out, we need to find the gradient of the tangent. Okay, because remember, your equation of the straight line is y is equal to mx plus c. So you need to find the gradient of the tangent. Okay, and how are we going to do it? We've only got the equation for the cubic function. So how do I find the gradient of the curve? Hopefully you all realize by now, to find the gradient of the curve, you derive. So what I'm going to do is I'm going to derive this expression, and that's going to give me the gradient of the curve. Okay. So using the power rule, remember, if you guys are getting confused with the power rule because you haven't done it, you will eventually get there at school. Okay, but it's the quicker way to derive without using first principles. So we take the power, times it by the constant in front of the x. 3 times 4 is 12. From the power of the x, we subtract 1. So 3 minus 1 is 2. Okay? For the next term, we do the same thing. Power times the coefficient. 2 times 12 will give me 24. From the power, I subtract 1. So 2 minus 1 will just give me 1. All right? Next term, the power here is 1. 1 times the coefficient of 9 is just 9. From the power of the x, we subtract 1. 1 minus 1 is 0, and we get x to the 0. But x to the 0, remember from exponents, is 1. So therefore, I don't need to put anything next to the 9, because 9 times 1 is just 9. The derivative of the constant 2 is just 0, so we leave it out. So this gives me the gradient of the curve. If I want the gradient of the curve at the point 3/4, all I do is I substitute 3 over 4 in place of x in the expression for the gradient. That will give me, importantly, the gradient of the tangent as well, because remember, where the tangent meets the curve, the gradients are the same. So if I use this 3/4 and I substitute it into the curve, into the gradient, I will get the gradient of the straight line at the same time. All right. So let's do that. We're going to say 12 times 3/4 squared plus 24 times 3/4 plus 9. Okay, this is going to give me 12 times 9/16 plus 24 times 3/4. 4 goes into itself once, 4 goes into 16, into 24, 6 times. So 6 times 3 is going to give me 18 plus 9. If you want to, you can use your calculator here. All right. 12 and 16, 12 times 9/16, let's simplify. We get 4 goes into 12 3 times, and 4 goes into 16 4 times. 3 times 9 is going to give me 27/4, plus 18 plus 9 is 27. So I'm going to get 27 and 27/4. All right, and you can use your calculator. I think this is going to give you like 28 comma something. All right, you can check that on your calculator. Unfortunately, I don't have my calculator up at the moment, so I can't give you the decimal answer to that. But it'll be 28 comma a few decimal places. All right, so what have I found? Okay, and it looks kind of strange, but what I've found is I've found the gradient of the curve at the point of contact. Okay, so the gradient of the curve at the point of contact is going to be 27 and 27/4. All right, now that we've got the gradient of the curve, remember the gradient of your tangent is going to be exactly the same. Okay, so therefore the gradient of your tangent is also going to be 27 and 27/4. So this straight line here, the yellow one, we know that M is 27 and 27/4. All right, guys, I don't like working with it in a fractional form like that, so I think what we're going to do is go through a quick break while I try and get the calculator up. All right, great, guys. So remember, we took a break because I needed to find the calculator and I couldn't do decimals in my head. Okay, so I've got the answer now, but I just want to go through with you what I've done so far. So if you've just tuned in, then, you know, we are in the middle of the example. So I just want to go through what I've done so far. We were asked to find the equation of the tangent to the graph at the point x is equal to 3/4. So what I did is I took the equation that they gave us of the graph, I multiplied it all out, and I got an expression, a cubic expression. Okay, we got this expression, 4x cubed plus 12x squared plus 9x plus 2. All right. I then, because I said, well, we need to find the gradient of the straight line, so therefore we know that the gradient of the tangent is equal to the gradient of the curve at the point of contact. So I derived the gradient of the curve, because remember, when you derive that, you get the gradient. So I derived that. I got 12x squared plus 24x plus 9. And then I substituted the point of contact, which was 3/4. All right, I substituted 3/4 in place of x, and I simplified it all without a calculator, and I got to 27 and 27/4, which was really not looking very nice. So I simply, on my calculator, took that and I said, what is that as a decimal? And we got 33,75. Okay, and we can write it obviously as a mixed fraction as 27 and 27/4, or as an improper fraction as 135/4. You can leave it in any one of these states. Okay, so now that we've got the gradient, remember, this is now the gradient, as nasty as it looks, it is the gradient of the straight line. So the gradient of the straight line is going to be 135/4, And then obviously we times it by x and we add our c on. So this is now the gradient of the straight line. We still need to find c. Now in order to find c, we need to know what the y value is at the point of contact. Remember, all we've got is 3 over 4, and we don't know what y is. Okay, so if I want to find the y value, I simply need to use my equation, which was given to me as y is equal to 2x plus 1 squared times x plus 2. So I'm simply going to use that equation because obviously it's the only one we've got to work with. So it was 2x plus 1 squared times x plus 2. I need to find the y value that corresponds with an x value of 3 over 4. So all I'm going to do to find that coordinate is I substitute 3 over 4 in place of x in the original equation. And let's see what we get. So it's going to be 2 times 3 over 4. You can put it in this form where we haven't expanded, or you can put it into the expanded form. It really doesn't matter where you put the 3/4 in. So I'm going to get 2 times 3 over 4. 2 goes into itself once, 2 goes into 4 twice. So we're going to get 3 over 2, which is 1.5 plus 1. So we get 2.5, hey, which is 5 over 2 squared times 3 over 4 plus 2, which is 2 3/4. All right, so we're just going to do that on the calculator, or you could obviously put everything on your calculator and just see what you end up with. So we've got 5 over 2, and we're going to square that, and then we're going to times it by 2 plus 3 over 4. And that's going to give me 275 over 16. As you can see, guys, the answers aren't really nice, pretty 1s and 2s and 3s. These are fractions, and it's real life. You get fractions and you get decimals. All right, so therefore our y coordinate is 275 over 16. So our point of contact is now 3 over 4 and 275 over 16. Okay. So what did I do? I used the 3 over 4, put it back into the equation of the cubic graph. That helped me to find the y coordinate. Once now I've got the y coordinate and the x coordinate, and remember before we saw that the gradient was 135 over 4, I can find the y-intercept by substituting everything back. So it now looks like this. Y is equal to mx plus c. Remember, it was y is equal to 135 over 4. And remember, in place of x, I've got 3/4. And in fact, I'm going to replace y with 275 over 16. And I simply need to solve for c. So c is going to be 275 over 16 minus 135 over 4 times 3 over 4. Obviously, you can do all of this on your calculator, which is the best way to do it. All right, because we're dealing with so many fractions. So we've got 275 over 4 minus...
Isn't it over 16? 275 over 16.
Did I make a mistake, Looney?
Yes.
It is quite possible.
So you had
275 over 16.
As
Oh, yay, someone is awake. Well done. All right, and that might just mean that we're not going to have time to finish it, but we'll check. And it's going to be 135 over 4 times 3 over 4. And that gives us minus 65 over 8. Okay, so therefore our equation, and we can end it off nicely, is y is equal to 135 over 4x minus 65 over 8. So it's 135 over 4 times x minus 65 over 8. And that is the equation of your tangent. It doesn't look very pretty, but sometimes you don't get equations that work out beautifully. All right, so guys, the one thing I want you to take out from this lesson, obviously remember to download our app onto Mixit, our Curio app, but also I want you to take out that the gradient of the tangent is equal to the gradient of the curve at the point of contact. That's what today's lesson was all about.
Now it's time for a break, so don't go away. We'll be right back. Welcome back from the break. I know you can't wait for the term to end and the July holidays to start. And of course, that means winter school. This year, we will be bringing you special exam revision sessions from the 1st till the 5th of July from 9 a.m. in the morning till 7 p.m. at night. We'll also be repeating the programs from 9:30 p.m. every evening. So don't miss out. If you want to do exam revision with other learners and get help from expert tutors, you can register for our winter school classes at a PC training center near you. Just go to our website www.learnextra.co.za/classes to get all the details. But for now, let's get back to revision. Over to you.
All right, so let's get to our first question. It's quite long, so brace yourselves. All right, now remember, whenever you're dealing with calculus functions, they're going to be long questions. Unfortunately, that's how it goes with cubic functions. But if you know all of the different ways that they can ask you these, it's easy marks. All right, so we've got f of x is equal to x cubed minus 12x squared plus 36x. The first part, A, says find the stationary points. Now remember, stationary points are points at which your derivative, your first derivative, is equal to 0. That's how we find stationary points. Okay, so all I need to do is I need to take my function, which is f of x is equal to x cubed minus 12x squared plus 36x, and I'm going to derive it. All right. Now, guys, before we actually get into that, I just want to discuss, although I will discuss it with you later on, if our general formula for a cubic function is ax cubed plus bx squared plus cx plus d. All right? Now, the two different shapes you can get. You can either get a graph that looks like that, which is concave down and then concave up, or you get a graph which looks like this. And this one you get when it's concave up and then concave down. This type, the first one you will get when a, that's the coefficient of x cubed, is greater than 0. And then the second one you would get when a is less than 0. So as I said, I'll come to that when we're recapping how to sketch cubic functions, but I just wanted to mention it now. So if we're looking at a function like the one we've got, x cubed minus 12x squared plus 36x, we can see that a is positive 1. So therefore, this is the type of shape that we are going to bear in mind. But it's also things that you can find by testing for your concavity and that. All right. So I've got my f of x. I need to now find the derivative. Okay, so remember your rules for deriving. F dash x is going to be 3x squared. So I take the 3 to the front, multiply the coefficient, and then subtract 1 from the power, minus 24x plus 36. All right. So that's my first derivative, but I'm looking for the stationary points, which means this has got to be equal to 0. I've got to equate it to 0 and solve for x. I divide through by 3 to make this a little bit easier, so I'm going to get x squared minus 8x plus 12 is equal to 0. And then we can factorize that trinomial to give us x minus 6 times x minus 2. So therefore, my stationary points will be at x is equal to 6 or x is equal to 2. All right, now remember these are just the x coordinates. You need to find the y coordinates. So importantly, you need to put this into the original function, okay? You notice I'm using f of x, not f dash or f double dash. So I'm going to find out what f at 6 will give me, and then we're going to do the same thing for 2. All right, so we simply substitute it into the function, okay? So it's going to become 6 cubed minus, okay, this was your function, x cubed, and so it's going to be 6 cubed minus 12 times 6 squared, and then it's plus 36x. All right, so it's plus 36 times 6. Okay, these can get quite long, and you can get funny decimals and that, all perfectly acceptable, right? So just be sure that you're putting the right things into your calculator. So we're going to enter 6, and we're going to cube that, minus 12 times 6 squared, plus 36 times 6, and we get 0. So therefore, f of 6, so 6, when I put in an x value of 6, I get out a y value of 0. So therefore, one of the stationary points is 6, 0. Okay, now we need to find the other one. So I do the same thing. I put 2 in place of x, and I'm going to get 2 cubed minus 12 times 2 squared plus 36 times 2. Again, just put it all into your calculator. So you're going to get 2 cubed minus 12 times 2 squared, which is 4, plus 36 times 2. And we get an answer of 32. So therefore, my other stationary point is 2 and 32. And guys, that's very, very important. When you've asked to find stationary points, it's not just x values, right? You need to substitute those x values that you find from letting your derivative equal to 0. You have to substitute that back into the function to get your y values. All right. Once you've got those, then you've actually got the stationary point, which, as you can see, are coordinates. So I'm quickly going to recap what we did before the break. We were given a function. We were asked to find the stationary points. So what we did is we let the first derivative equal to 0. We solved for x, and then we took those x values, put it back into the original function, and then we got our stationary points of 6 and 0, and 2 and 32. All right. The second part of the question, part B, asked us to find the point of inflection. Now remember, if you're looking for a point of inflection, it's where your second derivative is equal to 0. So all we do is we take the first derivative. Now remember, don't derive again the first time because you've already got that done. All right? So take that first derivative and just derive that. So our first derivative was, all right, so I'm just going to have to call it up again. There we go, 3x squared minus 24x plus 36. All right, so it was 3x squared minus 24x plus 36. We then derive that once more to get the second derivative, and we get 6x minus 24. Okay, so we derive that derivative, and we get 6x minus 24 as the expression for the second derivative. We need the point of inflection, so we need to equate that to 0 and solve for x. Remember, your second derivative is equal to 0, gives you your point of inflection. Divide through by the 6, so I get x is equal to 4. So therefore, at x is equal to 4, the graph is changing its concavity. Now we need to find the corresponding y value at which that concavity changes. So we simply take the 4 and put it back into, always when you're trying to find function values, use the function. So we need to use f of x. All right? So we put it into x cubed minus 12x squared. So it's going to be 4 cubed minus 12 times 4 squared plus 36. Okay, let me just double check that. Our second derivative was 3x squared. Okay, and our function value was x cubed minus 12x squared plus 36 times x. So 36 times 4. Okay, put that into your calculator. So it's 4 cubed. See, let's just do that again. It's going to be 4 cubed minus 12 times 4 squared plus 36 times 4, and we get 16. So therefore, our point of inflection will be at the point 4, 16. All right, remember your point of inflection means your concavity is changing. All right, now let's talk about more about concavity in the third part of the question, which says determine where the function is concave up or concave down. All right, so here we need to be looking at the second derivative. Remember, whenever we're testing concavity, we're looking at the second derivative. When your second derivative is negative, you have a function that's concave down. When your second derivative is positive, you have a concave up function. Okay, all right. So determine where the function is concave up or where it's concave down. What we do here, when we're testing the concavity, we look at the point of inflection, which remember is 4. So I'm looking at the x value of 4, and we then look at the sign of the second derivative. Okay, so I've just drawn up sort of like a table. It's not really formal. So I've got 4, which is my point of inflection, in the middle. And then we know that at 4, the second derivative is equal to 0, because remember, it was the point of inflection, right? Then I want to test the signs for x is less than 4. So I want to see what happens this way to the left. And then I want to know what happens when x is greater than 4. So what happens to the right of 4? That will tell me how the concavity is changing, because remember, concavity changing means it can either go from concave up to concave down or from concave down to concave up. So you need to know how is it changing around the point 4. Okay, so let's test. We look at the second derivative for any value of x less than 4. Now remember, your second derivative was, if we look at the expression here, it was 6x minus 24. Right? You just simply test. It's just a very, very rough test. So if I take any number less than 4 and put it into my second derivative. So for example, take 0, because 0 is less than 4. You're going to get 0 times 6 is 0. You're going to get a negative answer. So everything less than 4 is going to give me negative values, all right, for the second derivative. So if the second derivative is negative, we're looking at a concave down function, all right. You do the same thing for values greater than 4. So I look at my second derivative, which is 6x minus 24. I take any value for x, which is greater. So this is very similar to inequalities. You guys will remember inequalities from grade 11. Take a value for x greater than 4, like 5. Put it in there for x in your second derivative. You're going to get, for example, 30 minus 24, which is a positive answer. All right. So when x is greater than 4, our second derivative is positive. And yes, it will always work. It doesn't matter what values you take that are less than 4 or what values you take that are greater than 4. It's always going to work for any of those values. So you simply need to test one. If one doesn't work, then it means, you know, the whole thing's not going to work, but it'll always work. All right. So you just need to test one. You don't need to test every single value. Okay. So let's discuss this. What we've got is that for all values of x less than 4, your function is concave down. for all values of x greater than 4, your function is concave up. All right, so we're looking at something like I've drawn there. The concavity is changing, so it was concave down and then it becomes concave up. All right. Let's look at the last part of this, which says now sketch f of x. Okay. Now remember, because we're dealing with a positive function, I've already shown you what the graph should look like, but let's do it from scratch. All right, and guys, I'm obviously not drawing this to scale, but you will be given graph paper and that in an exam, and you can make a nice scale, and if it's necessary, to do it on a scaled graph. All right? Okay, let's just try and straighten out my axis. There we go. And now I want some of the key points. Now remember, the first thing we found was the stationary points. We had 2 and 32, and we had 6 and 0. Those were the stationary points. We saw that the point of inflection was 4 and 16. All right, and we saw concavity, how it changed around the point 4. Now remember, you have nothing else, because they haven't asked you in this question to find x and y intercepts or anything like that. So we're just drawing this function from looking at concavity. So what I want to do is I want to add in one more thing here. Let's look at what happens at the stationary points. How do we know if 2 is a local maximum or minimum? How do we test that? Now remember, I showed you this in the beginning. You look at your second derivative. If your second derivative is less than 0, you're going to have a local maximum. And if your second derivative is greater than 0, you're going to have a local minimum. So what you would do, okay, and I'm not going to do it, but I want you to try it at home, is you take the 2, substitute it into the second derivative and check the sign. Okay, is it positive or is it negative? Okay, check the sign of the second derivative and then also check the sign of the second derivative at 6 and see whether it's going to give you a local max or a local minimum. Okay, another way you can think of, how do I find the shape? Remember, I showed you right in the beginning, because your a value is positive, you are going to have a local max and then a local min, which tells you that 2 is going to give you your maximum value and 6 is going to give you your minimum value. All right, so you can also do it that way. But obviously, if they ask you for concavity, you need to use concavities. Right, I'm just going to plot the points now. So we've got 2 and 32, and as I say, this is not to scale. So 2 and 32 is one of the turning points. 6 and 0 is another one. And then we know that in between there, 4 was at x is equal to 4, we had our points of inflection. All right, so we're going to have a graph that looks like this. It's going to turn at 2 and 32 and then come down and turn again at 6 and 0. Okay, so this point here, remember to label these on your graph. That's the point 2, 32. And then at the point 4 and 16, which is somewhere there, you have your concavity changing. All right, so when you draw your graph, you need to exaggerate that, okay? The concavity needs to change. It needs to go from concave up to concave down. All right. Oh, sorry, from concave down to concave up, because that's what we worked out when we looked at the point of inflection and we saw that the concavity changed at x is equal to 4.
We've come to the end of today's show. Thanks for joining me and for chatting to me during the show. Don't forget to include Learn Extra Winter School in your plans for July. Go to our website, learnextra.co.za/live to get all the details. Also remember that if you are stuck on any questions, you can get help by sending an email to helpdesk@learnextra.co.za. All the best for your exams.